Factor each of the following. When we factor, we're trying to write our equation, our polynomial, in a different way. So currently all these polynomials are written in standard form. It means a form like this: x squared plus bx plus c. And we want to try to turn that into x plus or maybe minus some number times x plus or maybe minus some number. So we're trying to turn our polynomial into linear terms, into separate linear terms. This is useful in simplifying in, for example, limits in calculus. So how do we turn it into that factored form? For this first example, x squared plus 7x plus 10, it's a trinomial. That means it has 3 pieces. And our last number here is 10. So to factor, we're trying to think of what are the numbers that multiply to the number 10 that add to this, the b term, the x term in the middle, 7. So we're trying to find a product of 10 and a sum of 7. We're looking for a pair of numbers that satisfy this. So we could list out all the factor pairs of 10, 1 and 10, 2 and 5. We're looking for the pair that sums to 7. So that pair is 2 and 5. Therefore, the factored form of this equation is x plus 2 times x plus 5. Let's repeat with this second example. We're trying to find a product of that last number of -6 and a sum of the middle term, which reads -x. That means the coefficient there is -1. So we're looking for a pair of numbers that multiply to -6 and add to -1. So I'm going to start listing out the factor pairs. Here, since we're multiplying to a -6, that means we have to have one positive and one negative number. So 1 times -6 is a possible pair. -1 times +6 is a possible pair. 2 times -3 and -2 times 3. And we see that 2 times -3 is -6, and 2 plus -3 is -1. So those are our two numbers, and the factored form is x plus 2 times x minus 3. If you look at this third example, it's a little bit different. First, because the numbers are larger, but also, if you look, the lead coefficient of these first two problems was 1. 1x squared, 1x squared. But in this third problem, the lead coefficient is 3. So what we want to try to do first is we want to try to factor that 3 out of the entire polynomial. That means we want to see if 3 divides into each of these numbers so that we could get a simpler function. Let's see, divide by 3, divide by 3, divide by 3. So I'm going to pull a 3 out in front. And if we divide each of these terms by 3, we would have x squared minus 4x minus 12. And now we want to factor this inside polynomial with the 3 taken out. That means we're trying to get a product of -12 and a sum of -4. I'm going to list out the factor pairs of -12. 1 -12, -1, 12, 2 -6, -2, 6. This isn't all the factor pairs, but I see the one that we want. It's 2 and -6, because 2 plus -6 is equal to 4. And we get 3 times x plus 2 times x minus 6 for our factored form. Okay, this last example is written a little differently. It only has two terms, x squared minus 9. Since this only has two terms, our process is a little bit different. But I want you to notice something about those two numbers. X squared is something squared, and the number 9 is a perfect square. That means that we could factor this polynomial differently with a pattern that's called the difference of squares pattern. That pattern says that a squared minus b squared, the difference of two squares, or subtraction between two squares, factors to the square roots of the two numbers added together times those same numbers subtracted. So in this example, we do have the form a squared minus b squared, and we want to decide what a and b are to fit into this pattern. So I'm going to think about what's the square root of x squared, and I get that that is x. And what's the square root of 9? I get that b is 3. So then in this pattern, we're going to write a plus b, a minus b. So the factored form is x plus 3 times x minus 3.